Good evening, everyone, and welcome to N-Simplex Pachinko. This is Obi-Wan Pez. We are working on some math tonight. And if we get a lull anywhere in there, we will likely head over to Xena project, which is a programming project that is looking at basically increasing people's awareness and ability to program in Lean Prover, which they're trying to eventually teach an AI system to hopefully build math from the ground up, and then potentially be able to surpass humans in terms of like developing proofs in a rigorous manner. So, good luck. But if there's one thing a computer can do, it's anything that humans have done so far, and potentially get a little bit extra outside the box. Well then, good evening. Centripetal force. Some. Alright, that'll have to do for now. So if you get an object that is moving in a circle, I mean, really I should have just put that on an actual if I were smarter, I'd put it right here. Alright, so that our center point is right here. Alright, we have an object. It's going like this. And being swung around. Uh-huh. So when you throw a physics problem like that, uh-huh. Is this from your Calc 4 class? I really should have swapped out this book. Yeah. Alright, let's see if I can. Let's see, that is about a quarter of an inch short. Yeah, I think that'll do. You know what? It's just a bad idea to move this. especially right now. Well, I'll have to change that up later. So. Well, I mean, the unfortunate message here is that you have some slack to pick up, and there's gonna be there's gonna be some work that needs to be done. That just looks wrong. So you got a barge that's got a rope tied to it. Direction of motion is just going to be here in the X direction. And the horse is pulling here at 18 degrees. So, roughly speaking. Whoa. Nope. Horse is way too large. Oh, looks like a dog. That's fine. Alright, so horse is pulling that away. The force is being exerted this way. So it's looking like the horizontal component of this particular force is 7,900 newtons. At 18 degrees. $9,500 kilograms. This is 0.12 meters per second squared. Alright, that's all the relevant information. Then we want to know, what is the horizontal force of the water on the boat? want to say they're incorrect. And that... Nah, it doesn't matter. The current of the water doesn't exist. So since this is a man-made canal, I think they're assuming it's slack water. So there's no movement of the water itself. I think what they want you to do is they want you to say that this is going to be an equal and opposite force to what you've got here, with the exception of the fact that, well, it's not equal and opposite now, is it? Because there is an acceleration of this particular boat, which is actually going to make this force coming from the water only match out to about here. So this difference in the force, right, this change in the force that's between our positive force from the horse and our negative force from the water, the change between them, the difference between them, is what causes the acceleration. So I think that that's what they want. What they've actually typed is not quite what I think they want. So as far as I'm concerned here, I think that what they meant to type was that this will have the force of the horse pulling on the rope is 7,900 newtons. Not that the horse is pulling a horizontal component of 7,900 newtons, because that's a lot less work. Or, well, less work. 3 left seconds, how's it going? So yeah, the horizontal component of this work that's being done here, the horizontal component of that force is going to be 7,900 times the cosine of 18 degrees. Right, that is my understanding of probably what they want. Alright, so then we actually need to worry about F equals ma for this whole stuff in here. Still studying for the ASVAB. Very nice. My lowest score, auto mechanic. To no one's surprise. I think I knew a grand total of like 3 questions on there. All right. Yep. Can't say I blame you. All right. So the sum of the forces, or the net force over all this stuff, is going to cause mass times acceleration to be on the other side. Absolutely. Yep. You got any questions, drop them in. And I will answer it as is convenient. Alright, so 7,900 times the cosine of 18 degrees plus, because this is the forward component of the, yeah, absolutely. So, maybe. So let's try both. So we don't need to find the hypotenuse, because what we're concerned with here is the opposing forces that are working against each other on, like, in the water. We want to know what the horizontal force of the water is. We also want to know what the horizontal force of the horse is going to be. So one is, if we talk about this as the vector, is 7,900 newtons. The other is the horizontal component is 7,900 newtons. So let's try both. So either way, it's going to be the sum of the horse stuff and the force of the water that's pulling back on it is going to get us a net force of the mass, 9,500 kilograms, times the acceleration, 0.12 meters per second squared. And this is 9,500 kilograms, so kilogram meters per second squared is newtons, which is what we wanted for this. So this is going to be 12 by 95. Ugh, really? Why is my phone acting up? $11.40. Yeah, that makes sense. Alright, so here it's going to be the same thing. 9,500 kilograms times 0.12 meters per second squared, which is going to be 1,140 newtons, just the same. And then we're going to say, so if 7,900 newtons is the force by which the horse is pulling, or the amount of force that the horse is pulling, if 7,900 is the horse's force, then yes, the horizontal component is 7,900 newtons times cosine of 18 degrees. If, on the other hand, the 7,900 newtons is the horizontal force of that particular vector, just horizontal, just how much of the horse's force is being put into the boat. That's going to be number 2. Right, I'm saying it's worded poorly. Because why would they need to put the 18 degrees in there at all? Maybe it's just that they're putting superfluous information in there to make sure that you somehow confuse yourself. So let's just go with the second one then. Alright, so if we're saying 7,900 newtons is in fact just the horizontal component altogether, and that's the only thing we need, because again we want to know what the horizontal force of the water is. Now we're saying that the force of the water is going to be equal to 1,140 newtons minus 7,900 newtons. Oi! That's up 26 stacks. Alright, subtract 1140 from that. We get a 68, 67, 60 newtons. A little bit, yeah. So it's looking like the force of the water, force being exerted by the water, is going to be 6,760 newtons in the opposite direction. So yeah, barge is coming down the canal. Right. So I mean, since it explicitly says that is the horizontal force, I'm going to go with that and just say like, okay, the horizontal force is 7,900. And we don't have to worry about the other one. I'm going to say that this blue horizontal vector is just going to be 7,900 newtons. That's it. Oh, is this... does this also ask a question later on about what force the horse is exerting on the rope? That might be where my source of worry and confusion came from. Because again, it's not superfluous information that it's 18 degrees, if they ask that. Or something like that. Yep. One gustal. How's it going, Megalomorph? But only if he's eating 12 dozen eggs a day. Or 4? Oh boy. I forget the lyrics now. Yes, go for it. Yeah. When he was a lad, he ate 4 dozen eggs. And now that he's grown, he eats 5 dozen eggs. Every morning. No wonder the townsfolk are so worried. hours of tutoring all the last 3 in a row. Yep, that'd do it. Is this all in-person stuff? Alright, so 3 left seconds. Here we go. We have a problem which involves mostly unit analysis for being able to say, like, you know, do you understand the whole picture and how to manipulate all of the numbers that are on the screen? So, if an aircraft is traveling at 7.5 miles per minute and it's been traveling for 1.5 hours, then that's fair. We notice that in this particular case, we've got a problem with units. So this one's talking about minutes, and this one's talking about hours for time. So not really going to work for us 100% just as is. We do have to change some of that. Yep. So numerically, the way that you do this, and this is for much more complicated stuff, right? This one's pretty easy. You knew instantly that 1.5 hours is 90 minutes. So, ta-da. But again, for much more complicated stuff, what I would recommend is that you say, okay, 1.5 hours, we're going to multiply by, we know that we want to get rid of hours. So that particular unit should be on the bottom. And then we want minutes in order to match. So we have 60 minutes per 1 hour. Times the 1.5 hours. So hours and hours are going to divide out. You can put this over 1 if you feel like it, or just leave it as a number. It doesn't have to be done like that. This is the number that we have, and again, to convert this, or to actually, we don't want to convert this. If we just want to multiply, here we've got miles per minute, here we've got minutes up in the top. So, 7.5 miles per minute. Eventually what's going to happen is our minutes here will divide out with our minutes there. Now again, you already know that this is just going to be, well, this is 90, and then we have that times our 7.5 miles over here. So this is going to end up with 75 times 9. So your decimal place is off somehow. You're doing 90 by 75. So that's miles. And again, this is going to be 750 minus 75 is going to be 675 miles. 6850 though. Interesting. It seems that you're carrying an extra 1. So if you're multiplying it on paper, alright, then you're doing 90 by 7.5. When you multiply, we're saying that this is going to be 0. This is going to be 45. Alright, crossing, bring that over. This is going to be a 7 times 0 is 0. Yep, 7 times 0 is 0. And 7 times 9 is going to be 63. So here, 0, 5, 7, and 6. So 6750 is what it looks like. However, there's this little pesky thing here. Our decimal place has to be carried through. So we have one number that is behind the decimal place. And so down at the bottom, there is one number that needs to be behind the decimal place. Essentially what we did was that this lower part here is 90 times 75. But at the end, we need to take the 6750 that we have. Oh. Ah. Yeah, that'll do it. Right. So what we need to do at the end is say that, well, we need to take our total from this multiplication, our 6750, and then divide by 10 because we need one decimal place to be captured down here. So that's what gets us our 675. Gross. So, 3 seconds. This is an extremely helpful comment, even though it may not seem like it right now. So if you can break numbers down into constituent parts, then a lot of times you can trade around the factors that you have inside these numbers, and it's a lot faster to try to figure all this stuff out than to like have to go through and do the paper stuff, which is really what ASVAB, or at least this section of ASVAB and the timed section are going to be dealing with. So the timed arithmetic section is just going to be like simple calculations, stupidly simple calculations that are just going to be as fast as you can answer like 50 problems that are addition, subtraction, multiplication, division of no more than 2-digit numbers, I believe. Yeah, especially when they start using different ones, like hours and minutes, representing the same type of unit, but using them in a different way, or using them with a different unit. So doing the conversion is really the important part. Alright, that's just evil. So 5 gallons. Again, you can take this as, if you've got 5 gallons as your initial amount, and we want to get this in terms of quarts, then we know that, again, gallons is in the numerator here, so put gallons in the denominator to get rid of it. So those will divide out to just be ones, and then quarts. S, not Z. Alright, for every 1 gallon, there are 4 quarter gallons. So that's there. Then, if we want this in pints, then you're going to need to know what the conversion factor between quarts and pints is, which I don't know offhand. I think it's also 4. Or is it 2? That's fair. Now, I, unfortunately, will not be eating ice cream. Very sparingly at this point. Pints in a quart. Cool. 2. It is 2. I never remember this stuff. Yeah. 2 pints per 1 quart. So again, cross out your quarts, you got pints. So then 5 gallons in pints is going to be 5 times 4 times 2, so you get 20 times 2 is 40. So this is what is needed. And then you said has was 3 quarts plus 1 pint. Yep. Yeah, you can always just make change however you're going to make that work. Not Z. Yeah. So, 1 American gallon is 128 fluid ounces. 1 quart is going to be a quarter of a gallon, so 32 ounces. And a pint is going to be 16 ounces. I know that much. Now. At some point, we're all just going to say feck it and go with the metric system, but you know. I'm still telling you, all we need is like sometime in the next, in the one next presidential term, turn, you know, say like everything across the country already has the metric amount on it. It already has it. So in the next presidential term, just make it like 50% bigger than the imperial unit. And then in the next presidential term, make it another 50% bigger than the imperial unit. And then eventually, people just won't use it anymore. It'll just drop off. People like me, we're going to get stuck with the whole, like, oh no, I guess we're going to use metric. And then we're going to get, just our brains are going to get fried. But we'll deal with it, especially, you know, scientifically minded people. Not a problem. And that one town in Arizona that has everything in kilometers and nothing in miles. You can tell that this one is a bird and not a plane because it has feathers. Okay, so same deal again, really, is that unit analysis is going to be your friend. So put the thing we have here. Say this needs to be equal to some number of miles per hour. It's true. Then we say here, you need to convert minutes to hours again. I guess we didn't do that last time. We could have last time. Right. Oh no, we did. Minutes and hours. Yeah. So here, 60 minutes to 1 hour. We know that much anyway. But 60 minutes to 1 hour. And then here we can multiply. So this is going to be 120 over 3 times 1. So 120 miles in 3 hours makes 40 miles per hour. Well, that's the secret. This is just an expression. You just have a number, right? You start with a number. So 2 miles per 3 minutes, or 2/3 of a mile per minute. Same deal. And then what we want to do is to convert it into miles per hour. Technically, you make it an equation by putting an equality sign there. But you don't really need to. I just do this because that's my goal. I want miles per hour. And then we do all of this with the units in order to say, you know, our minutes are going to divide out. We get ones for those, and then it's just miles here with hours there. So as long as those are in the appropriate location, then you'll be all right. The bird one. So this is actually the same as the plane one, and also the same as the unit one that we have here. You know, the ultimate question that they're asking is slightly different for them, but honestly, it's all the same process. You start with some sort of right. So this gave us a conversion. Sorry, this gave us a thing that we needed to multiply. Reason being, they wanted us to have a goal of how far did it fly. So our goal was miles. We don't know what it is, you know, ahead of time. So we know that we started with 7.5 miles per minute. And we know we started with a measurement of time, which if you think about it in terms of like a formula that you remember or stuff like that, then this is going to be our good old distance equals rate times time formula, right? A distance that we want is going to be our rate, the speed at which we're going, times the amount of time that we're going to travel. And we said that our distance is unknown. Our rate was going to be 7.5 miles per minute. And our t value was 1.5 hours. But then this has a dimension mismatch because our units are not the same. So because this is in minutes and this is in hours, we have to convert it. You knew automatically that 1.5 hours is 90 minutes. But what I'm saying is, what if they said it was 1.1 hours or something like that, or, you know, 7.6 hours? You don't want to be able to, or you want to be able to just go for whatever you need and not necessarily rely on, oh, well, how many minutes is it? Well, it's a nice number. So if this is not a nice number, some other amount, then you want to say, okay, in order to convert this thing, what we needed to do was say that we needed to take, in order to convert it, we needed to take 7.5 miles per minute multiplied by 1.5 hours multiplied by hours in the bottom, and again, minutes on top. So here, this was 60 minutes to 1 hour. Will get us hours dividing out here. It'll also get us minutes dividing out here. And now that we do that, we can do the individual things. So 7.5 times 1.5 times 60, or again, you knew 1.5 times 60 just gets you 90, and then 90 minutes multiplied by 7.5 miles per minute just gets you 675 miles. So when we moved on down here, again, we have 5 gallons. Yeah, if it's like 1.3 hours or whatever, we're multiplying it by 60 because that's 60 minutes per 1 hour. And I don't necessarily want to get you into the habit of just, multiplying by a specific number. Because again, if it changes, it's going to be kind of distracting. You're going to be like, oh no, now I'm screwed. No. If you learn it, this way with unit analysis, then it's always going to be the same thing. It's just a matter of knowing what the conversion factor is between these things. So in this particular case, right, we've got 5 gallons. We would like to have this in terms of pints, just to knock it down, to be able to say, all right, instead of, sometimes, instead of having it in gallons, let's knock it down to pints. So we said in terms of gallons, we know that 1 gallon is 4 quarts, and I looked it up, but nonetheless, each quart is then 2 pints. So by multiplying those values, you end up with 40 pints is the same as 5 gallons. And again, we would have done the same here, but you figured out the answer real quick. So it's like 3 quarts. We'd take and multiply it by 2 pints per 1 quart. Quarts go away. And then we've just got 3 times 2 divided by 1. It's going to be 6 pints. And then we add the 1 from here. So our amount that we had was 7. So in this particular case, we need 33 pints. And then, like you said, 33 pints is just a quart and a... Yeah. Is just 4 gallons and then a pint. That's what I meant. All right, and if you wanted to get it all in terms of fluid ounces, you could do that too, but like, eh. All right, so then this one at the bottom, again, it gives us a goal. So our goal is the unit. It doesn't necessarily mean anything else. So we just want the unit to be miles per hour. So how do we get miles per minute to become miles per hour? Again, it's going for 60 minutes rather than for 1 hour. So if this is 2/3 of a mile per minute, then we're multiplying by 60 to get it in terms of miles per hour. Right, it being a longer time period, hours being a longer time period than minutes, the number is going to be bigger because it's going to be traveling further in that same amount of, in the longer amount of time. It will be traveling a farther distance. And it's really just going to take practice. Hooray! All right, Blainlin. No problem. All right, so centripetal force is going to be that force that is going to be pulled on the object by the virtue of the fact that it's being held in place by this rope. So as it's being swung around in a circle, the force of the object on the rope is then going to be this centripetal force. Right, the equal and opposite force that is being pulled on the rope itself, because of, again, the object that's here, is the sort of fake force that we call centrifugal force. So it's the force that the object exerts on you holding the rope, based on its acceleration and its mass and all that stuff. Alright. And if this thing is being spun in a circle, then its centripetal and centrifugal forces will be exactly equal and opposite. They're canceling each other out, so they're just forcing this thing to go around in a circle. So if we have like a 1 kilogram mass going around let's say it's a 1 meter rope. So this means that its circumference, the distance that it travels all the way around, is just going to be 2 pi meters. Or about 6.28 meters. And let's say it makes that journey in 1 second. So that means that the force should be, and correct me if I'm wrong, anybody who's actually paying attention, our mass being 1 kilogram, it's going to be multiplied by the distance, which is going to be 2 pi, over 1 second. And then we take that, we need to square it. Now, mathematically speaking, this works out. In terms of physics, I'm not 100% sure that this does actually pan out, but we can find out. got to be some way in which I can derive it, right? Alright, this is kilogram meters per second squared, so again this is going to be like 2 pi newtons. Alright, so mv squared over r, which is v squared. mv squared is kinetic energy. Interesting. Ah, 1/2. That is a rather interesting little diversion there. So let's just check that real quick. Centripetal force is equal to m v squared on r. So mass was 1 kilogram. V squared, it's doing 6.28 meters per second. Uh-oh. No. I'm wrong then. Alrighty. Alright, so 6.28 by 6.28. We're going to multiply ones by ones to get our ones column, so that's going to be 64. To get our tens place, we're going to multiply tens by ones and ones by tens. So that's going to be 16 twice is going to be 32, plus the 6 we had over here is going to be 38. To get the hundreds place, we need to multiply our tens by tens, our ones by hundreds, and hundreds by ones. So it's going to be 48, 96, and 4 is going to be 103. And then to get our thousands place, this is going to be hundreds by tens, and tens by hundreds. So 12 and 12 is 24, plus 10 is 34. And to get 10,000s, that's going to be 6 by 6 is 36, plus 3 is 39. Then we got 4 decimal places, so 1, 2, 3, 4. So 6.28 squared is going to be 39.4384. Now, of course, this is pi squared, not actually, or 2 pi squared, not actually just 6.28 squared, but it's going to be close. So actually 39 newtons, not 6. So like the frequency would be the number of times it goes around in a second, probably. And it might be listed as hertz, something like that. Oh man. Oh, I see. So you get an 18-degree incline here, you get a 27-degree incline here, which is between the top edge and the part that the truck is actually towing on. Alright, so the gravitational force on the car. No. Gravitational force on the rope. very nicely selected 45 degrees. Hey yo, welcome. My name is Obi-Wan Pez. This is N Simplex Pachinko. And thank you for the follow. So the gravitational force that is applied to an object begins increasing as an object gets closer to a particular planet or whatever. So here, gravitational force is going to point directly toward this line here. Sure, I'll go with that. And then when this moves further ahead in its orbit, let's say here, the gravitational force that this object is feeling is, first of all, going to be, again, pointed in this particular direction, but it's also going to be much larger. So why exactly? Well, it turns out that Newton came up with the law of gravitation, which technically is only a theory, in that it is not mathematically robust once you start looking beyond simple objects. So once you start looking at like really small, really big, or things that are moving fast. But the force according to gravity is going to be equal to the g gravitation constant force, which is a constant, times the mass of the first object times the mass of the second object, so the product of their masses together, divided by the distance between them squared. So if our distance is a really massive number, and then you square it, that becomes a much more massive number. If our distance is a very small number, and you square it, it becomes an even smaller number. And the thing with fractions is that when you're dividing by a really, really small number, the whole fraction itself becomes really, really big. Yep. Which is also why things that are really, really far away, yeah. And then generally speaking, forces in general are going to be equal to their mass times their acceleration. So as the force gets larger, yes, as the force gets larger, the acceleration gets larger because the mass is not changing, generally speaking, right? If it's a comet, sure, it's throwing off mass, but then that's also going to mean that as it's losing its mass, its acceleration is going to start climbing. Its gravitation force is also going to drop slightly because it is losing mass. But if it's a comet, right, and it's going around the sun isn't losing significant amounts of mass. So it's just going to zip harder in toward the center of the solar system. Yep. So as we increase our gravitation constant, that's a bad place to put it. Right? As we increase our gravitation constant because we get significantly closer to an object, then our mass is going to stay, again, roughly the same. And in order to balance, our acceleration has to go up. So the feeling of it is going to be that it will feel heavier. So it will have then a centripetal force, which is applied as it's going around. It's going to accelerate inward toward the planet in the direction of the force, right? In the exact same direction as the force. It's accelerating this direction. And if it accelerates toward the planet in that particular direction, then it's also going to have the centripetal force is going to make it feel like it's going to be heavier. Yes, so Blaine, let's talk about if you throw a penny from a tall building. Two birds with one stone here, right? Can be. So most of the time, at least in Algebra 1 and 2, we're talking about throwing an object, and we'll just deal with its height as a function of time. So this is going to be something like negative 4.9 t squared plus 10 meters per second times time plus what is that, like 400, 300 meters? I don't even remember. You know what? Yeah, let's just do 300 meters because. Right, so most of the time we look at this and we're just saying, all right, this is just going to be the equation that we use for this particular scenario. So 10 meters per second upward, initial velocity, and 300 meter initial height. So if you want an angle, there's two steps to this process. One is to find the tangent at the current location, specifically the slope of the tangent line, because when you get a tangent line, then you're saying, oh, well, this now has an angle to it, theta. Yeah, no problem. See you around. I do math nights on Tuesdays and game nights on Fridays. At the moment, just trying to play some spooky games because it's October and we're doing Soba. Well, sure. But you don't need to worry about it too much because the slope is, in fact, a trigonometric function. So here, if we take our initial value, this is going to be, again, negative 9.8t plus 10. No, it's fine. Now here's the thing. This only deals with height. And time is on our t-axis. This does not have to do with the actual angle of the object being thrown. Oops. Alright, if we want the horizontal, then probably what we've got is a set of parametric equations. One representing the x values and one representing the y values. So what we have in the x direction is going to be based on 1, the initial velocity, and specifically the initial velocity in the x direction. Which is our velocity component times time. Then we've got our initial value, x sub 0. Then for y, what we've got is our, first of all, acceleration due to gravity. So this is going to be 1/2 at squared plus v sub y times t plus y sub 0. All right, so let's say that the horizontal component is, I don't know, 3 meters per second times t, and we have no initial x value. We'll just call where we started 0. So x equals 0. And then y here equals 300 as our initial value. Y of t is going to be 1/2 that negative half times negative 9.8 meters per second squared times t squared times, let's say that the vertical component to this velocity is 8 meters per second times t, and plus 300 for its starting value. Yeah, you don't need to do any work. Because here, we've got our components to this. So that's a right angle. This theta. Our horizontal component is going to be 3 meters per second. Vertical component is 8 meters per second. You want to know what theta is? All right, well, find the tangent. So tangent of theta is going to be 8/3, which means that theta is going to be the inverse tangent of 8/3. So if you got that, great. If you don't, then you can also work as the so the slope of the tangent line will be that. It's just more involved. Takes a bit more practice, a bit more doing. So this is the fun part. Where's a pavement? So we know that y is going to be equal to 0 when that happens. So we set that equal to our negative 4.9t squared plus 8t plus 300. All right, easy enough here. This is going to require us to take the quadratic formula. So t is going to be equal to, this is going to be a negative 8 plus or minus square root of 8 squared is 64 minus 4a is negative 4.9 times c is 300. I'll divide by 2 times negative 4.9. Negative 8 plus or minus square root 64 plus 5880 all over negative 9.8. Negative 8 plus or minus square root 5944 Alright, not a particularly nice value. And we know for a fact that this is going to be the positive answer because the negative answer is back here. just no. So we just want the positive one. Now in this particular case, keep in mind the denominator is negative, so it's going to be when the numerator has those two negative numbers. So 77.09 plus 8 is going to get us 85.09 divided by positive 9.8 is going to get 8.68 seconds, give or take. Realistically, 8.68 seconds is about as accurate as we're going to get. But the thing about where in this particular case is that we didn't want a time value. We wanted, like, how far away is this object now? So what is our x distance at this particular time? Well, this one's at least somewhat easy. It's just going to be 3t. So 3 times that amount. It's going to be 26.05. Oh. X at 8.6830. No, 3402. Yeah, right. Whew. It's just 3 times 8.6834 which is going to be equal to, again, 3 times that is going to be 26.0502 meters. Realistically, 26.05 or just 26 meters, probably good enough. All right. Anything else we want to talk about? force of gravity on this car is going to be 1200 by negative 9.8 by cosine of 45, which is root 2 over 2. It's going to be a negative. And 1200 by 9.8 is going to be 11,760 divided by 2 equals 5880 times 2 square root equals. Alright. Force of gravity is going to be a negative 8,315.5757, and there's a bunch more stuff after that, newtons. Then, the component force based on, or the tension that's going to be held on the rope, it's going to be equal to that particular force, the force of gravity, multiplied by cosine of 18 degrees. No, I have that backwards. Force due to gravity. Gravitational force of the car itself, really from its center of mass, whatever, is 1200 times negative 9.8 times the cosine of 18 degrees. So that is going to be multiplied by 7,765 0.32 newtons negative. Tension on the rope. It's going to be the force of gravity. I believe this is where we introduce the 45 degrees. Tension on the rope should be equal to a 5,490.91 newtons. In theory. What did it say? The rope has a breaking strength of 4.6 kilonewtons. So that's not going anywhere. Somehow, I think that probably I'm making an incorrect calculation. This would not surprise me in the least, so... Getting a lot of Harris Heller here. Ooh, cell dweller. Upgrade to premium. Yeah. Fine. Someday. Okay. let's switch gears here and look at the Xena project for just a few minutes. So the Xena project is an attempt, like I said before, in order to help an AI system, rudimentary AI system, be able to figure out mathematics and see if we can be able to prove any particular propositions and things like that within mathematics. So give it kind of a boost to help it understand what mathematics is, and hopefully teach the computer system to do basic logic type stuff. Alright, so if you go back to the tutorial world, this is the natural number game. So if you go back to tutorial world, you'll be able to get a sense of how lean is supposed to work. Put this in the chat here. So this is the link if you're at all interested. Addition world allows you to construct the entire structure of mathematics, or the field of the real numbers. We're starting there anyway. We start building things that use addition, so doing commutative property, associative property, and all sorts of stuff. Basically, we can take a few things for granted, and then you have to prove the rest. In multiplication world, it does much the same stuff. So I have level 1 completed here. So for all natural numbers, we have that. Yeah, y'all can't see that. Cool. That's the same song. What the hell? Also the same song. That's a bit of a different vibe. There we are. So in order to prove that 0 times m is equal to 0, given all natural numbers m, we have to say, all right, let's start a proof by induction. So we're going to show that, given any particular value for m, we can start with a specific value, show what happens, and then move on from there. We have so far done... Okay. So induction m with d, hd, is saying that we are going to have M is our original statement. No, M is the natural number that we have, my nat. With D is going to be our dummy variable, and HD is going to be the statement that allows us to use it to prove by induction. So, first is, let's plug in 0 for M. So when we plug in 0 for M, we get 0 times 0 equals 0, which, based on, if we rewrite, multiplying a number by 0 gets us 0. We knew that from before. So multiplying a number by 0 gets us 0. That then gets us that 0 equals 0, and then we use the reflexive property to clear that particular segment. Then on the next one, this is rewrite mul suck. So this is multiplication of successive values. So this here, rewrite tactic, is going to take our original 0 times successive d equals 0. So again, in an induction proof, we're saying that for the next number, whatever that next number may be, this is also going to work. So do multiplication of successive values. Successive d turns into d plus 1. And then when we have 0 times, parentheses, d plus 1, this is going to end up being 0 times d plus 0 equals 0. Give me 1 minute here. Hey everybody, just real quick, I'm gonna run out and grab something. So, let me put on I guess, 3-minute ad, whatever. I'll be sitting here doing nothing, so, I mean, I'm going to be out there, but the stream will be doing nothing, so, just a few minutes. Okay, so we're back. Okay, so Bertram, welcome in. This is the Xena project, which is basically trying to like break down algebra into a logical system in which we might be able to someday teach an AI system, rudimentary AI system, how to do mathematics and how to prove math. So eventually the goal is to be able to let this AI system loose on mathematics and see if it can come up with something new, or something maybe just a different insight than what humans are typically used to. So, I was discussing here, we're trying to prove that 0 times m, so for some natural number m, is equal to 0. Yep. So in order to actually do that, we have to call an induction on m. So when we do an induction on m, this is going to take m and say, all right, let's show that this works for m equals 0. So we use the known property that when you multiply something by 0, you get 0. So note that this is backwards compared to what we're using. So if we say do an induction, then it calls that we're going to say that m is 0. And then we rewrite multiplication 0. So something times 0 is going to be equal to 0. In this particular case, 0 times 0 is going to be replaced with 0 on the left. So 0 equals 0 is a reflexive property. So we use that and it clears the goal. Then the next goal becomes, we want to say, all right, suppose that this is going to be true for all HD, which is 0 times D is equal to 0. Now we want, how do we do 0 times the next number? So the next thing after D is also equal to 0. Prove that that's true. So the ones that we are allowed to use are that the way. Almost. There. It's a terrible idea. Let's move me. No, not that. There we go. Let's move me to this corner because there's nothing here. That makes much more sense. Okay. No, I'm all out of whack. So anyway, over here on the left, right? What we have here on the left are the two things that we can use in the multiplication world. The multiply by 0, so a times 0 is going to be equal to 0, which again we said 0 times 0 is equal to 0, so we're good with that. And multiplication of successive terms, so a times the successive of b is equal to a times b plus a. So it's essentially distribution. We're saying that the successive of b is b plus 1. And so in this case, a times, parentheses, b plus 1 is going to end up being a times b plus a. So when we rewrite multiplication successive, we see that a is equal to 0 here, times the successive of d is going to be 0 times d plus 0. So that's what we got there. And then we say, well, look up here, 0 times d was 0. We already said that, so we can, first of all, okay, did it backwards. First of all, we can add 0. So within the addition world, a plus 0 equals a. So 0 times d, whatever that might be, is going to be equal to, or plus 0 is just going to be equal to 0 plus d. So add 0 to it, it's just, 0 times d. So 0 times d equals 0, which is literally everything we have in HD. So rewrite HD, 0 equals 0, do the reflexive property. Proof complete. Alright, next level in multiplication world is that we want to take, we want to prove that multiplying a number by 1 is going to get that number itself. Again, it seems like it should be ridiculously easy, and it should be, but you can't just say, well, yeah, it works. You have to show that it works, in such a way that a computer will look at this and say, yes, absolutely. So force and induction on M again, with DHD being our statements. So D is going to be our dummy variable, HD is going to be the statement that it relates to. So the first goal is, again, plug in 0 for M. So if we plug in 0 for M, we get 0 times 1 equals 0. 0 times 1 equals 0. And then we know that we can do a 0 multiplication from our multiplication world here. So again, you got to check like the multiplication world theorem statements every time to see what is allowed. 0 mole we just proved on the last one, so that's why we can use it now. So 0 times M equals 0. Well, yeah, that's what the first one is. So we already know that works. Do rewrite 0 mole. We get 0 equals 0. That's a reflexive property. End goal. Then we say, again, we can assume HD. So D times 1 equals D. And then we have to show that successive D times 1 is successive D. So this next one is rewrite 1 equals successive 0, or the successive number 2, 0. So this is going to say that 1 is going to be equal to the successive of 0. So successive D times successive 0 equals successive D. Then we can use mulsuc, which we just had on the previous one, to say, okay, well, now we can multiply successive D, the A from this other one, to both of the individual terms. Again, distribute. So successive D times 0, which now we can do multiply by 0 again. Clear out the first one. Then we can do 0 added to something is going to be that something by itself. So now successive D equals successive D. Reflexive. Proof complete. Level 3, go backwards. So 1 times M is going to be equal to M. Again, you can't take any of this stuff for granted. Any of it. You have to prove anything if you want to use any of it at all. Which, you know, to some people this is really tedious, and yeah, it can be. But overall, it makes just a fascinating exercise in like trying to prove how all of this has to work. So again, do an induction with M, or on M, with DHD. So now plug in 0 for M. 1 times 0 equals 0. Yes. We can multiply by 0 because we just proved it. Right? Just proved it. Multiply by 0. Oh no, there's a couple. Oh no, mole 0 is given. Okay, never mind. That's not what we want. 3. Right, so we end up with that. Again, rewrite multiply by 0. 0 equals 0, reflexive. Then the next one was, again, we got successive D in those places. So do the mulsuc thing, because that allowed us to separate the successive D into D and 1, or plus D and a plus 1. Rewrite the HD because 1 times D equals D was assumed to work. So now we got D plus 1 is successive of D. Well, successive equals add 1 to something. So D plus 1 equals D plus 1. Cool. That works too. Alright, distribution. Does distribution work? Again, you have to prove it. So we have to do induction B, second number here, with DHD. plug in 0 for B. So now we could say on the on this one here, A plus 0, we're going to add 0. Rewrite multiplication by 0. So t times 0. Rewrite as 0. Add 0, so ta plus 0 is just going to be ta. Reflexive. And then again here, successive. So rewrite successive is add 1. So now it's d plus 1 on the inside of this thing. Rewrite in the opposite direction the associativity property involving A, addition. So this A right here should have its parentheses reversed, so that's A plus D plus 1, I think. Okay. Yes, technically. There's a thing that happens inside of this particular structure. Whew, goodness. Alright, so in addition to that, then we say that we're going to reverse the idea of successive is a thing plus 1 and turn A plus D plus 1 into the successive of A plus D. Multiplication of successive values now makes us t times A plus D plus t times 1, or just t. Rewrite HD, so t times parentheses A plus D is going to be the same as t times A plus t times D. So here this is going to be replaced. And now if we look at it, it's very similar. Rewrite successive equals add plus 1, add 1. So that last one, D plus 1, turns into successive D. And then T times successive D, we're going to rewrite as T times D plus T. Rewrite associativity property, so lose the parentheses there. T times A plus T times D plus T equals T times A plus T times D times T. Reflexive. Alright, so we can do the same with multiplicative associativity. Real short proof for it. And then we're on number 6. Now I've gotten through all of Multiplication World before, but they changed some stuff and the protocols behind the scenes, and I lost all my progress. So I'm trying to complete this. I'm trying to complete Function World, which is the next one over, and it's been going okay. This is a little bit like the Euler project, where you're trying to come up with some sort of interesting programmable solution to be able to come up with an interesting proof for this particular thing. Whereas in the Euler project, you do only have to get the right answer. You don't necessarily have to have like a nice program that does the thing. It could be a total kludge and not at all robust. I try to make my programming as robust as possible so that if somebody wanted to plug in any particular value, it would work just fine. Not just the one that happens to be called for in this particular situation. Tonight, Elder Pine Brewing and Blending Company, Berry Chaser Imperial Fruited Saison, 1 pint, ale brewed with raspberry, blueberry, and black currant, 10% ABV. Yowza. This is the only thing I'm going to have, and it is going to conk me out. So I better finish stream the next hour. Drink responsibly, drink slowly. And always remember to double fist. Water is super important. So, on this one, I am doing something that is failing. That's where I'm at. So we've got all these things over on the left-hand side. We're doing an induction on A with THD. So it says that the successive of 0 is equal to B time, or no, successive of 0 times B is equal to 0 times B plus B, which if we rewrite successive equals add 1, then we get this 0 plus 1 times B. We're trying to prove successive multiplication rather than multiplication of successive terms. So, alright, rewrite 0 multiply. Gets this 0 times b over here to just be 0. And then we got 0 plus b, which we can now add 0. This line here is to do a repetition. So we're going to add 0 plus 1, and we're going to add 0 plus b to get, respectively, 1 and b. So 1 times b equals b. Rewrite 1 multiply. B equals b, reflexive. Then, given that successive d times b is equal to d times b plus b, we need to prove that the successive of b times b, successive d times b, is equal to the successive of d times b plus b. So if we rewrite as hd, this ends up taking the right-hand side, taking successive d times b, and writing it out as d times b plus b. And then we said, okay, what should we do on the left here to be able to do something? And this is going to say, okay, if we rewrite successive equals add 1, then we take the successive of d and make it d plus 1, and then take the successive of d plus 1 and make it d plus 1 plus 1. And then all of that times b. And then now we're stuck. So So let's suppose that this is a mistake. Or potentially we only want to do it once. So if we only do this once, this makes successive of D plus 1, successive of D plus 1 times B. Alright. Back it off. Suppose that's a mistake. It's like, that's the thing we're trying to prove, so I can't just say it. Right, we haven't done left. We haven't done left distribution either. So add mul will be something that we need to prove later. Right now we have mul add. For anybody who's still around, how y'all doing? fault of the drink. Sends all your alcohol is a vasodilator, so it sends all of your blood vessels into open mode, which then releases as much heat as it possibly can. So we're getting a little warm in here. Just something to learn if you haven't heard about that yet. All right. Okay. So what if we do a reverse of distribution? I don't think that's where we started, right? No. Okay. So rewrite, oops, rewrite backwards. Mol add comma. No, really? Man. Oh no, because B is second, not first. We haven't done commutivity yet. Whatever. All right. Okay, fine. Doesn't exist here. might just be stuck here again for a while, so that's alright. If anybody sees anything that's helpful, let me know. So again, multiplicative commutivity isn't going to come around for a while. Check some of the other stuff that's here. So addition world and the tactics. No, it's not gonna work there. Okay. Wait. I may need to do... Ooh. Actually, successive addition. Okay. So left side is now successive parentheses d plus 1 times b. I'm not sure that helps me at all, but so if we have like successive multiplication, that's what we're trying to prove, right? Successive multiplication, yeah. Okay. Oh, rewrite HT. That's not what I meant. Repeat. Rewrite HD. No, you should do it on the left. Okay. This is so stupid. Come on now. Alright, so... Yeah, it's not doing the left-hand side. That's slightly frustrating. Right. D plus 1 as A? I don't think that works. Yeah. Yeah. So if you look ahead, right, this is going to be admol. So this is our right distribution. Deduction. I don't remember which one would be easiest here. Let's try B, I suppose, with DHD. And this is going to be rewrite, add 0. Rewrite 0 mole. Rewrite, add 0. Flex it. Okay, so that clears that, which means that we could have done 0 mole first. Ooh, ooh. What'd I do? What did I just hit? Okay, appears that I just went to the next tab. Oh. What the hell? Oh no, I closed it. Ew. The hell? Oh no. I don't know what I did. Okay. And then we can repeat. RW at 0. Wow. Okay. So it just went and solved it, or told us that it was done. Okay, I'll take it. Alright, so we're going to have to rewrite suckmole. Rewrite additive associativity. No? Really? That thing at the bottom. AT plus parentheses D times T plus T. I'd really like you to move that over. If you can move the parentheses around, A times T plus D times T. Pretty sure that would help in some way, shape, or form. Probably not, really, honestly. No, actually it would. You can force one. How do you do that? No. Parentheses. I wanted them to take this and do... This is suckmole, so you can't make that work. What did I say? I wanted them to reverse. Them to reverse distribution. I'll add T times A plus B. but worth a shot. No, multiplicative associativity. So A times parentheses. Oh, no, additive associativity. Oh no, it did work. I must have been doing multiplicative. Well. Oh. Alright, so those two there. We have alright, so rewrite backwards HD? Question mark? Yes. I screwed myself over here. Do we have something that's like A times B plus B? Guessing no, because that's kind of what we're trying to prove. But all right. Well, we made some decent progress in a couple of these anyway. I think it is going to be time to move on to Boss Lady. Tonight, Boss Lady B is playing The Complex, so this ought to be interesting. I haven't seen this one yet. I will be back on Friday for game night, and if anybody else is interested, I will be playing Soma. I've just made it out of the first complex and tried to make it over to, I believe, Theta or something like that. And I will be back on next Tuesday for more math. So if anybody's interested, come on in, stop on in. I look forward to seeing you. Have a good night. This is Obi-Wan Pez for Ensign Pachinko.